Hey guys, it's Joran with another coding interview question, and this one is called number of islands. I personally like this question. I think it's a good example for the type of questions that kind of look like it's going to be an array or 2D array problem, but then they end up being a graph problem. And there's a lot of this type of questions out there. And once you figure out that it's really a graph problem, you're like 80% done. So it's really good to know this type of questions. And yeah, you'll see what I mean. So the problem is described like this. We are given a 2D grid map where each cell contains either land or water, and we want to return the number of islands. Okay, so an island is defined just like you would expect. It is a collection of land cells surrounded by water. So in this example, we have two islands, one here, and then the second one here. Okay, so the correct output for this example would be 2. In this example, we also have two islands, one here, and then the second one here. And notice that we only care about these 4 directions, the top, right, bottom, and left directions. So even though these two cells are diagonal neighbors, and intuitively we might think they should connect, they're really not connected. They belong to 2 separate islands. So just keep that in mind, that the only directions that matter for this question are these 4. So for this last example, we have 3 islands, one here, one in the middle, and then the third one here. So for this example, the correct output would be 3. Okay, so let's start to think about the solution. So we're definitely going to need a loop that iterates over the cells, because we're going to check each one. So starting from this top left cell, we're going to check if the cell contains water or land. Now, water cells do not really provide any useful information about the number of islands, right? So we can just ignore them and move on. Now, when we encounter land, we know that we are definitely on an island, right? We don't know the size of the island or which other cells belong to this island yet, but we do know we are on an island. So we can increase a counter for the number of islands. But now we don't want to just move on and then count this island again, right? So what we want to do is, once we see land, we want to mark the entire island as visited and not just the current cell. Okay, so we mark the entire island as visited, and then when we see it again, we know not to recount it. Now, the easiest way to mark the island would be to replace its land cells with water, because when we see water cells, we just continue without taking any action, which is exactly what we want to do for visited cells. Now, at this point, I would ask my interviewer if it's okay to modify the input data. In the real world, it is bad practice to do that. For the sake of an interview question, it will probably be fine, but it is a good idea to mention it, so you show that you know that you're creating a side effect and you wouldn't normally do that. So in case it's not okay to modify the data, you can just use another data structure like a hash table or a duplicate matrix to keep track of the visited cells. For simplicity, I'm going to assume that it is okay. So I'm going to replace the visited cells with water. Okay, so next thing we need to figure out is how to find all the cells belonging to the same island. So if I'm on this cell here, I want to find all of the other cells that belong to the same island. So first, let's replace the little drawings with numbers. So we have 1s for land and 0s for water. Okay, so back to our question. We want to find all the cells belonging to a particular island. So basically what we need to do is we need to look at the cells as nodes in an undirected graph. There's an edge between 2 nodes if both of them contain the value 1 and they are adjacent to each other either horizontally or vertically. Now, the main thing to notice here is that each island forms a connected component. Okay, so you can basically reach all of the nodes in an island with a simple graph traversal. Both BFS and DFS will work. You can choose whichever one you prefer. I'll choose DFS because the code will be simpler. For example, if I trigger a DFS from this node, I will reach all the nodes in its island. And I can easily just mark them as I go. I can replace their value with 0s as I go. And then by the end of the DFS, this island will be completely gone. So obviously it will not be counted again. Okay, so let's quickly write the code for this. It's going to be really simple. We're going to start from the main function. And let's first keep a variable for the number of rows. That's going to be grid.size. Then I'll check if it's not empty. If it is, then there is definitely 0 islands, right? And then calls. Okay, so exactly like a pseudocode, we need a counter for the number of islands. So islands count starts at 0, And then we want to loop over the cells. So it's going to be just simple nested for loops. And then if the cell contains land, you want to increase the island count and then replace the entire island with zeros. So let's call this function replace island with zeros. And we'll need to give this function the grid and then the current cell. Okay, so now let's implement this function. This is basically just a very simple DFS. Okay, so first thing we do is we replace the current cell's value with 0. Okay. And now we want to iterate over the neighbors of this current cell. And we have 4 directions, the top, left, bottom, and right directions. Okay, so let's just do a for loop that iterates over these directions. Okay, so I'm going to need another variable for these directions. There are 4 directions. For each one, there's a column index and a row index. So first we'll have the top direction. So we would want to reduce 1 from the rows and then not change the column, so 0. And then the next direction would be left direction. So we want to keep the rows as is and then reduce the column. Next we have the bottom direction. So we add 1 to the rows and we leave the column as is. And the last direction is the right direction. Okay, so now back to this function. The new neighbor is going to have these coordinates. Its new I would be the current I plus their 0. And then its new j is going to be the current j plus their 1. So if this neighbor has the value 1, we want to recursively call this function again to remove all of its neighbors, right? So if its neighbor has the value 1, I just realized. One thing that we left out is that we need to check that the new coordinates are valid coordinates, meaning they're not less than 0 and they're not outside the grid somehow. So let's add this here. We'll write this function in a second. So if all of these conditions apply, we'll want to call this function again with the same grid, but with this current neighbor. Now, last thing we need to do is implement this valid function. It's going to be pretty simple. Then we also need these two. So let's just keep it here. Rows and calls. And then we need to return the counter. Okay, so I think we're good. Let's try to submit this. Okay, it's a success. We passed all the test cases and the time is pretty good as well. So just a few words about the time complexity. It's going to be linear to the size of the matrix. So if it has m rows and n columns, the time complexity would be O of m times n. And that's because in the worst case, we will only look at each cell a constant amount of times. Okay, so that is it for this video. I hope you enjoyed it. If you have any questions, you can leave them in the comment section, and I will see you next time. Thanks for watching.